Now let us consider two blocks at this position and suppose that there is no friction between these two blocks and between lower block and the rod. We assume that there is a force on this system applied to the lower block. The magnitude of this force and masses of the blocks are given. The question is to find acceleration of the lower block at this system. One of my students suggested the following solution. He considered these two blocks as a system, and because there is a force on this system, he used the second Newton's law in this form, where M capital is the sum of masses of these two blocks. Then we can apply this law and find acceleration as force divided over sum of the masses, M1 and M2. This gives us 10 meters per second square. Very simple solution, but unfortunately it is wrong. Where is the mistake? The mistake done by the student is that he didn't take into account different scenarios of motion. Before formulating these scenarios, let's watch the video with the experiment of motion of two blocks. Now let us consider the simple experiment which illustrates the possible scenarios of motion. You see a comparatively large block and a small one. They will put this small block on the large one. First I will apply the small force on these two blocks. So I accelerate the two blocks with comparatively small force, and you see that they move as a whole. Now I will increase the force first slightly, and you see that the upper block moves differently from the lower block. If I apply large force, then you see they move absolutely in different way, with different acceleration. Let's now summarize the results of this simple experiment. So the first scenario, which is possible, is that blocks move with the same acceleration. Very simple scenario. The second scenario, more complicated, is when blocks move with different accelerations. In this case, the upper block can move with respect to the lower one. And we denote the velocity of motion of the second block with respect to lower as v21. The first scenario was selected by the student. So he assumed that two blocks move with the same acceleration. What does it mean? Let's consider the first block. To move with acceleration a, it's necessary to have a force which acts on the upper block and accelerate it. From where can come this force? The only source of horizontal force in such a problem is the force of friction between M1 and M2. Because in formulation of the problem it is given that friction is absent, surface is frictionless, there is no source of such force. That means that the scenario 1 is not possible. It is a wrong one. So we can conclude that the mistake of the students was that he selected a wrong scenario. Now we consider another scenario, scenario 2, and assume that M1 and M2 blocks, they move with different acceleration. Actually, in the absence of friction, there is no horizontal force on the upper block from the lower one, and for this reason, this block remains at its initial position with velocity equal to 0, during entire motion of the block M1. Let's illustrate this motion on this diagram. So first block M1 moves with acceleration to the right, and the upper block falls down later. What is the conclusion? The force F is applied only to block M1. It doesn't affect block M2, and the acceleration A1 can be found using the second Newton's law. Acceleration equal force over mass, and in our case is 12.0 meter per second squared. I just remind you that the student got another answer, which was 10 meters per second squared.